So we're going to be talking here about OpenStack orchestration and automation. And I'd like to say a few words right out of the gate. This talk is about not the deployment, the automated deployment of an OpenStack infrastructure. It's about the deployment of effectively arbitrarily complex environments in your OpenStack infrastructure. So think of, for example, the ability or the requirement to build up a server infrastructure that consists of multiple virtual servers, multiple virtual networks. They're all connected with various virtual routers and so forth. Okay. So that's what I'm going to be talking about. There's an assumption that I'm going to make, and that assumption is that you know OpenStack. If you are a complete novice in OpenStack, then most likely, if things like firing up a new Nova VM or creating a new neutron network, or assigning a floating IP, if all that is completely new to you, then probably you're not going to take that much out of this talk. If you do, then I think I can show you a few very, very handy tricks of the trade in order to greatly speed up your application and infrastructure deployment within an OpenStack environment. So this talk does assume familiarity with basic OpenStack concepts. It's not for OpenStack novices, but if you are running OpenStack, then I think I can show you one or two ways of using OpenStack that maybe you haven't seen before. I do have very limited time here, but I'm still going to try and do 2 short live demos. If you wish, then you can follow along with those. I've put up a URL here. If you clone this Git repo, then not only are you going to see all my slides, but you're also going to see 2 config files that you can effectively deploy onto your OpenStack environment right now today. So if you have access to an OpenStack environment from here, then you can just clone this and work along with me. And of course, if you snap the QR code at the top of the talk, then you already have access to the slides and you can find this as well. All right? Is there anyone else that still needs to note this down or copy this down? Or else I can carry on. Are we good? Give me a yes or give me a thumbs up. All right, cool, that works for me. Of course, if you want to follow along with this, then you're going to need an OpenStack environment, right? If you don't have one right now, or you don't have access to one right now, then you're not going to be able to follow along. But if you're not able or not inclined to follow along, that's totally okay too. In that case, just listen, and the other part of the slide I don't have to mention in Israel because it's a given anyway, right? This slide was originally done for a talk that I gave in Germany, and Germans I always have to specifically remind to please actually ask questions. Here I thankfully don't need to do that. So we're going to talk about automation, and specifically the automation of virtual systems in OpenStack. For those of you familiar with Nova, when you do a Nova boot, what can you customize? What are the things that you can just shout out? What can you...
Image network.
What is that? Image, yes. So what image do we want to boot off? What networks do we want it to be part of? What else? What is that?
Availability zone.
Availability zones. Flavor, yes. Host, yes, if you're an admin. What else? You can inject a secure shell key in there, right? And then you can do arbitrary customization. How do we do arbitrary customization in Nova? Arbitrary customization of a new VM. What is that? Okay, what's the Nova boot parameter to inject something that Cloud Init can actually work with? User data, exactly. So Nova user data. We all know Nova user data. So a typical Nova boot invocation, an invocation of the Nova command line, might look like this. And yes, I do realize that there is a unified OpenStack client that you can use for this as well. But assuming that you're using Nova, then you do a Nova boot, and then you specify, okay, what's the image? You can inject a key, you can define a flavor, you plug it into a virtual network, and then you use user data to upload your user data script. Now, what a user data script typically looks like is something like this. So for most people, they will just use a user data script that's effectively a shell script or anything that's interpretable. Cloud Init will identify anything that starts with #bang as an interpretable executable script. And then we do something that is normally arbitrarily complex, right? So we do something to initialize the box, and then we apply various provocations to the box, and then we're finally done. right? Who's done this sort of thing before? Basically inject a shell script into a Nova Boot environment or a Cloud init environment. Okay. Please stop doing that. This is a really, really poor way of customizing your VM. Just think for a moment about, say you want to install Git or for something, just application X, whatever application you like. If you want to do this in a shell thing, then either you're going to have separate Cloud init files for every guest distro that you want to support, pretty much every image type, or your shell script is going to be horribly convoluted and is effectively going to be like, okay, test if this box is Ubuntu, and if so, do apt-get install. Or if it's CentOS, then do yum install. Or if it's SUSE, then do zipper install or whatnot. That's horrible. And it's, funnily enough, you can actually do much better. We can all do much better and write much better Cloud init user data. Who in here has heard of Cloud Config? Yes? Just a few, right? Pretty much like out of a crowd of where I'm assuming that pretty much everyone has at least booted a Nova VM at some point, there's only very few hands that go up when you ask them, well, what's Cloud Config? Cloud Config is a facility that enables you to bootstrap a newly booted VM to a remarkably complex degree, and you can do all of that in YAML. If you ask me, Cloud Config, or that specific feature of Cloud init that parses this Cloud Config, I think that's actually OpenStack's most underrated, most underused, and at least until recently also most underdocumented feature. And since it comes out of Ubuntu, or comes out of Canonical, for me it also qualifies as Ubuntu's most underrated feature. They originally came up with it, and I'm actually not sure if they came up with it first for EC2 or for OpenStack, because for some time they were supporting both. But they basically brought it into OpenStack, and then everybody jumped on the bandwagon. And now Fedora supports it, CentOS, RHEL all support it, SUSE supports it, everyone supports it. But it originally comes out of Ubuntu, and few people even realize that, or don't even use it, which is like really weird, because you should use it. What can we do with Cloud Config? Well, the thing that comes in like really, really handy, I think, is who in here uses Ubuntu Cloud images? Right? The ones from like cloudubuntu.com, whatever it is. And you all realize that they actually respin these images daily, right? Just so you have like the latest security upgrades in there, which is great. But the problem is that most OpenStack environments will not refresh their Ubuntu Cloud image on a daily basis. You might be running other guest operating systems, like CentOS, for example. They do updated images, I think every point release or something like that. So at any given time, you can assume that if you're booting off of an Ubuntu VM or an Ubuntu image or a CentOS image that you have in your cloud, most likely it is going to be outdated, and in the interim, there's probably going to have been a few security upgrades that you really totally want to install. And that's really easy to do and simple to do with Cloud Config. All it takes is effectively 2 lines to set 2 Boolean variables. They're called package update and package upgrade. And if you set both of these to true, what they will do is they will just update your system on the first boot. And this is how you do it. Cloud init, when you inject user data, Cloud init will detect either is the user data executable if it starts with #bang, or is it Cloud Config YAML when it starts with #cloud-config. That's all the header that you need to put there. And then if you set package update to true and package upgrade to true, it will just do the right thing for your distro or for your platform, for your image that you're using. If you're on Ubuntu, it will use apt-get update and upgrade. On CentOS, it will use a yum update, and so forth. So that's one thing where it's exceedingly useful, and all it takes is basically 2 lines of YAML compared to like a bunch of shell scripting, which is patently useless at that point. There's more that you can do. For example, you can define users and groups right there from YAML. What this means is we're creating a user named foobar with the full name of Fred Otto Oscar Bar, put him in the users and atom groups, set a hash password for him, set a shell, and we can even give him some sudo privileges such that it can do passwordless sudo. If you just put a user like that by itself, it will replace the default user, which on Ubuntu is normally named Ubuntu or EC2 user, and on other platforms they use different names. But if you have the magic keyword default in that list, then it will also do that, plus any other users that you define. Once you do this, maybe what you also want to do is actually enable secure shell password authentication, right? Into an OpenStack or into a Nova guest. Well, there's few things that are actually easier than that in Cloud Config. You just set a parameter named SSH pwauth, and you set that to true, and boom, password authentication is enabled for your secure shell. Another thing that you might want to do is just write a file. Well, for that we've got write files. It looks like this. You can effectively define a path, permissions, ownership, and then you just set the file content. And in case you're not familiar with that YAML construct, the pipe simply means what follows is a multi-line variable where you're supposed to preserve the new lines. And so this is how we can, for example, pre-populate an etc host file if that's what you want to do. Who in here uses Puppet? Or Chef? And of those of you who use either Puppet or Chef, do you also use Puppet or Chef to configure your cloud guests? Yes? Well, why wouldn't you, right? Okay, now if you try to configure a Puppet client or a Puppet agent from Cloud Init using a shell script, that would not be fun. It would be a horrible endeavor. When instead you can do it with a few simple lines of YAML with the Puppet dictionary that you can put in there. So this is what it looks like. It just says Puppet, you define a configuration, you set the Puppet master, that just gets put into etc puppet puppetconf. You can also roll out your CA cert and boom, off you go, and your new VMs can properly be configured from Puppet. So what you do is you do a very baseline configuration with Cloud Config, and then you hand off to Puppet to do the rest. The same thing you can do with Chef, where you configure a VM Chef client. Again, you basically point it at a specific Chef server, and then there's a boatload of other options that you can set, all of which is much simpler than just doing this from shell. Another thing that I already mentioned, you might want to install packages, right? Install a package, but not have to care about what the actual package manager is on that specific box. So for example, you might want to install Ansible and Git, so you can subsequently do an Ansible pull on that box. And then finally, you can also run effectively entirely arbitrary commands directly from Cloud Config. And the way you do that is with boot command, which is a command that gets run really early in the boot sequence. Like for example, like this. This is also the thing that I used in Germany, right? Because that's like the most important thing for them, is that everything has to be on time, including all the servers. So that's, I thought that may be a good idea to just ground.
It might be a few hundred milliseconds difference.
Yeah, I know. It's
Germany?
It's pretty tough. Yeah, but NTP is good enough, I hope. This runs really early in the boot sequence if you want to run a command like after everything else is done, or maybe you want to provide some functionality for which you don't have YAML yet, then you can just use a run command. So here's an example. What you might want to do is you might want to run Ansible pull after you're done with everything else, and perhaps you might want to do it as a specific user and whatnot. And there's a bunch more options that you have from Cloud Config, and I've only sort of scratched the surface, but all of this is definitely better than hacking your own shell script. The next thing that you obviously want to do if you want to build and customize full environments is heat. Okay, heat, not an acronym, right? Well, it is an acronym. It stands for High Explosive Anti-Tank, which is something that you typically don't want in your cloud. But heat, as in the OpenStack context, it was called heat because heat is what makes clouds rise, right? So, hence the name. What we can do with heat is, with heat we can deploy complete virtual environments, including networks and routers and whatnot. Heat supports two distinct formats. One, it has copied effectively from AWS the CloudFormation template syntax, which is JSON based, and it has its own, which is called the Heat Orchestration Template Language, which is based on YAML. Now, what can we do with heat? Well, the thing that most people will pretty much always use in a heat template is a resource type called OS Nova Server, and it does what it says on the tin. It configures a Nova guest. It may look like this. We define a resource, we call it mybox, we boot it off a specific image with a specific flavor, and we inject a specific key. And now we could create this stack with a simple heat stack create, and off we go. As it is, however, that is not extremely flexible. So we can add some parameters, and what we can add to our to our hot template is a stanza called parameters, just like we had resources in the earlier example. Parameters have a name, they have a type, they have an optional description, and they have an optional default. If you use a parameter and you neglect to set it, and it has a default, then it will just use the default. If it doesn't have a default, then it will just flag an error and say, hey, I need this parameter, give me this parameter. And then we make use of one of Heat's intrinsic functions, namely the getParam function. So Heat has this concept of intrinsic functions. getParam is one of them. So what we can do here is we can simply define a Heat template that sets all of these parameters from the outside, effectively. And this is how we can set them. It's effectively you do a heat stack create, and then you either add these key value pairs for parameters with dash uppercase P, or you can also set a separate environment file, or you can also set this through the OpenStack dashboard, obviously, through Horizon. Now, a VM on its own, it's not going to help us very much, right? Specifically in the cloud, specifically where it runs in some sort of overlay network and whatnot. So would it be nice if we could get some network connectivity here as well? And for that, we have the resources called OS Neutron Net and OS Neutron Subnet. And we can use those to effectively define these subnets. And we can then also we have the neutron network type, which is effectively abstract, and then in order to actually make it usable, we also define a subnet with a CIDR address and an allocation pool, and we can enable DHCP and whatnot. One thing that you may notice here is in the network line where it says get resource, which is just like getParam, is another intrinsic function. And what's important about this intrinsic function is it not only allows us to cross-reference between resources, but also creates automatic dependencies between them. So Heat effectively builds up its own dependency graph such that it knows, well, if we've got this, where we have this one network here and then another resource that references it with get resource, then obviously we'll have to create the one at the top first and then the one at the bottom. So it's not procedural, it's not as it is described in the YAML, but it actually uses these automatic dependencies. What you also might want to do is now we've created a new network, we've created a new server, of which we might have 10 or 15, who knows. Maybe we also want to be able to set external network connectivity. Well, what do we need for that? We need a router, and we need to set what that router's gateway is, and we need to set a router gateway router interface. And this is also something you can define in Heat. So here, maybe you want to define like your external network, your public network, and then you want to include that with your resources. And then, of course, we can also define neutron ports, and we can define security groups. That's very helpful. And we can also set floating IPs, which means that we can make these VMs accessible from the outside in our new network. And now here, okay, so you're getting a floating IP from Neutron. You might want to know what that floating IP is. Well, for that we have outputs. Just like we have resources and parameters, we also have outputs, which enable us to return values or attributes from within the stack. And again, we just use this in YAML. Again, here's a new function called getAttribute or getAttr. And we can simply retrieve an attribute and then make it available to our user. And I'm going to demonstrate that in just a second. And then we can get this back out. Now, of course, what you want to do in order to be able to like fully automate everything, you are going to want to integrate Heat with Cloud Init. And one way of doing that is this. You just define a Nova server, and then you define user data, and you use yet another intrinsic function called getFile to include YAML from somewhere else. But there's something much cooler that you can do, and that is a specific resource type called OS Heat Cloud Config, and that allows us to manage all of this cloud config stuff directly from Heat. which means that we can now inject into Cloud Config, basically directly into our VMs, parameters that we can set on the heat level, like so, where we have so up at the top is the Cloud Config resource, doesn't have any parameters yet, and at the bottom we see how we can resource that we can reference that from user data with the get resource function. And then we can, of course, set those Cloud Config parameters directly from heat such that it may look like this. So perhaps we want to be able to say from heat what our username is going to be. And that's exactly what I want to try out here. So let's see if we properly appease the demo gods. Alrighty, so I'm headed into my temp, and here's my git checkout, and you can find that. Well, I can basically go right from the top, right? So I can do. Let's just remove that, and then clone this thing again. GitHub.com OSIL orchestration. There we go. Okay, and now the first thing that I could do is I just take a look into, for example, my Cloud init. There we go. So this is what my Cloud config looks like here. Very simple. We do a package update, package upgrade, and we roll out a few users. We enable secure shell password authentication for this, and then we also write some files, right? And then just for the fun of it, we also install Ansible and Git, and then echo hello world on the command line and issue the current date. So if I now want to do that, there we go. That's my Nova boot. I define a flavor, I boot off of a specific image, I inject this as my user data, and then I plug it into a specific network, I inject my key, and off we go. Whoops. I should use credentials with that. And if the Wi-Fi is not failing me here, then off we go. So that's a Nova VM that I just booted. So let's do a Nova list here. That should only take a minute or two to spawn. It's already active, wonderful. So we can do a console log here. And we should see this thing boot up. There we go. So that's just a regular Ubuntu boot. And we should see Cloud init kick in here in just a second. There we go. That's the regular Cloud init configuration for the network. And now we should see the other stuff that Cloud init is doing here. As you can see, that's our apt-get update that's running. So the only thing that I had to set in my configuration for that was a package update equals true, and that's it. And there isn't a whole lot that should be updated here. Well, there's a few updates. Okay, that's the latest Linux kernel update. So that we see fired up here. Okay, so that is going to take, what? Oh, cool. my home directory is running out of time, running out of space. That's a new one. I've not had that before. Okay, let's see if I can still do a Nova list. Ah, too bad. Let's see. See, it did not appease the demo gods enough. See if this does anything. There we go. Okay, so that's that. And by now this thing should be done. There we go. And that's completed. What I can also do, and of course you can also try this if you clone this thing, is here's my hot configuration. Just a few parameters. I define my flavor, my image. I set some defaults for that, and now I want to create a specific username with a specific full name, and then I use this as a user data resource. Here's the my config. As I said, it doesn't make a difference at all whether or not that's in what order that is, because it builds its own dependency tree. And so here we go with the cloud config, and here's where I inject my username. And are there any space geeks around here? No? There we go. So what I want to do is I want to create the stack now. Again, I want to inject my key. I want to use the M1 small flavor. I want to inject a username of skateboarding astronaut. And the full name of that skateboarding astronaut is obviously Colonel Chris Hadfield. And then I bump that into that specific public net, and then I fire this thing up. And now what we're going to see is effectively sort of the same thing, except that now it's a full stack. Which also involves a new neutron network, a subnet, a router, a specific port, even a security group. So I can use that thing. And let's do this. Here's my Nova list again. There's my box. Let's do a Nova console log of my box again. Okay, that's coming up. That's also doing the quick Linux update. So we're going to give it another 2 minutes, and then we should see this. Up. Because I'm almost running out of time, I'm doing my final housekeeping before. So if you want more information, which I think you will want to, this is the reference documentation for Cloud Init. Like I said, Cloud Init was woefully underdocumented until not too long ago, but it's actually pretty good right now. And you find the official documentation at cloudinit.readthedocs.org. This is a set of examples, like all the stuff that has not as yet been documented properly in Read the Docs. And this is the reference for HOT, so the reference for the heat orchestration template language. If you want these slides or you want any of this material, it's all under Creative Commons Attribution Share Alike license. The top is the rendered slides, the bottom are the GitHub sources. And if you want to know what I do and my company does about OpenStack, please by all means feel free to land on our hastexo.com/OpenStack landing page. We're a professional services company that provides consulting and training services on and around OpenStack. And finally, we should see whether this thing is done. And it is. And now we just fetch our public IP of that stack. And now we want to log in as skateboarding astronaut at There we go. And we do, and we're in, right? And all that, like really simple, no shell scripting, no nothing horrible like that. Okay, and with that, I am unfortunately out of time, but I will put this one back up. So those of you who who snapped the URLs earlier, just snap this, put it through Google Goggles or through your barcode scanner, and you'll just have these slides. All right. Okay. Well, I'll be happy to take the question, but I don't really have time to answer it. So can we take it offline? I really don't want to eat into the next speaker's time. All right? Okay. Thanks very much, and enjoy.